नहीं करता था।
मैंने वो बोला तेरा ठीक क्रैश जैसे
अरे वो देखो मैं बात बता दी
फिर बस डालने सच्ची में डालने की क्यों कटो भाई सच्ची में मैंने कटवाया था एक बात 100 साल पहले मुझसे क्या वगैरह इसको मुझसे मारा
मैं पहन के नहीं गई थी, मेरी मम्मी ने लकीली उतरवा दिया था।
देख तेरा मम्मी में ड्रेस का था अभी तक से बात कर रहे हैं
वो आपसे फैमिली को भी बुलाया फैमिली को
तू कभी भी ऐसा बात कर तेरी सली
काम में ना
तेरी शक्ल नहीं वैसी ना छोड़ेगी
इसका सीन क्या है फैमिली को बुलाया उसको कैलेंडर लेके बुलाया था मतलब डायरी लेके बुलाया था सब वो अपने नॉर्मल वाले स्कूल कैलेंडर लेके गई तो उसके प्रिंसिपल ने डायरेक्ट फेंक के मारा उसको कैलेंडर का मारा मॉनिटर डायरी चाहिए थोड़ी चाहिए तो वापस से मॉनिटर डायरी चाहिए उसको डाला क्योंकि उसने कल ना आज का और उसको बोलो पार्टी तेरा आधार कार्ड रजिस्टर हो रहा है मॉनिटर डायरी
you also cut it
yeah we decided to do it see I love her she loves me हमारी healthy happy relationship है तुम क्यों interfere कर रही हो
I don't know either of you both of you should
see I love her she loves me why are you bringing yourself in it
देखो कैसा बनी है अभी मेरा दिमाग खराब हो सकता है लोग का अच्छा दिन रहो मेरा बहुत ही बेकार गया है क्यों है क्या लगता है सबसे बेकार लोग मेरे लाइफ में आते हैं क्या हुआ मेरा मन एक्सप्लेन करने का
it's okay you don't have to explain it's fine
whatever it is now is getting related to studies
मेरे पास कोई चीज़ है क्या
इसको पेलना तो बोल नहीं देखो देखने नहीं लगता मैं प्रोफेशनल पेलर हूँ एक्चुअली
किसी बहन ने पेला तो बोले ना पेला छोटी बात है कैसे पेलेंगे
नहीं मैं बोलो के मार देती थी कोई आइडिया नहीं है क्या करती मेरी बहन अब पीट लिया
वॉल्यूम टूटा है oh my god
right volume is not the cute part of the relationship
I didn't want that. I didn't bring it.
but then we volume to meant for each other
वो बट दोनों चीट करते हैं
Then you bring volume to
वो दूसरे लड़कों का थोड़ी घूमती है दूसरे लड़कों का सेक्स करते हैं यही चलता है
भाई इन लोगों का हेल्दी नहीं है बस हैप्पी है
हाँ भाई और उन दोनों को पता है ये चीज होती है
तो रुके क्यों है भाई मैं होती तो मैं पहले भागती
वो लोग क्यों भी रिलेशनशिप है अभी भी वो लोग रिलेशनशिप में
अरे इन लोगों को और कोई
अच्छे रिलेशनशिप में है क्यों
इन लोगों को और कुछ चाहिए
दोनों मतलब एक दूसरे को सॉर्ट करोगे एक जैसे रहेंगे
किसी एक को goes along with the struggle and the biggest four boys who were to go on
और कोई कम नहीं है वो
मेरा आप ध्यान में उसको देखा तो उसको पता है तो इन्वेस्टिगेशन टेक्स्ट करने की कोशिश की थी लाइक मैंने रिप्लाई नहीं किया था उसको बाद में 1-2 दिन बाद पता चला ध्यान से उसको बहुत ड्रामा हुआ इनका अभी तो दे डोंट इवन टॉक
करते हैं बे बात
करते हैं पहले यू नो
Did you have a bad day? Did you have a bad day?
अब देखो ये समय के लिए टाइम कैसे गए
हां
इसलिए मैं क्या आता है
Good evening, all of you. Why the room is changed?
it always changes from this to that
So that's the innovation you go through. Huh?
Yes.
All right, first things first. Sit down. Come on. It's your house. She was like, kept me on task in the last class. Okay, so I have got some feedback from you guys. One of the students has really not liked my teaching. And he or she has failed me on all parameters. I'll read it for you. It's interesting. Don't take it too hard. It's not a complaint. I just want to know. I just want to tell you. In case you don't understand, just feel free to ask. Okay. So it's all right. You're yet to write any test, right?
Yeah, we haven't written any test.
Okay. Okay, so the feedback was invited on explanation skills. So there are two students who have given their feedback. One says excellent, other says needs improvement. My score 0 on improvement, excellent 2. Max score is 2. I get 2 points if I do well, okay? Then pace of teaching needs improvement. Excellent. So two contrasting views. So I think, and there's one more. Class discipline, excellent. One Sanpada student says excellent. He is from 10th ICS, you know. So 9 se ek hi nahi diye. Okay, sorry. So in this batch, there's only one student who has given feedback. Then homework quality needs improvement. I haven't given you any homework, have I? Have I given you any homework? Graphs, practice and all? Okay. So, okay, there I agree. Homework quality. So today you're going to get solid homework. Just have fun, okay? Have fun. It's not a complaint. But teachers also should be evaluated. I'm of that view. So, innovation. I need solid improvement there. Professors' overall rating needs improvement. So I got nothing in me. And then improvement required for physics teacher UDAYS in explanation and doubt solving. Wow, I thought that's my forte. Anyways, so only thing is, I'm not complaining against the student. I hope you are serious in rating. These things are viewed seriously, okay? So rate anybody seriously. Just imagine you write any answer and we just say, hey, come on, take this. So you should be justified and feel free to ask question. Okay? If you don't like anything, just say it. That's okay. Don't keep it inside. Okay? This is not your school. I'm not a teacher who's going to punish you. So you can talk to me. But not like her. I'm scared of her now. Okay.
She gives spoilers.
No. Oh, so video.
No, we did not harass her later.
Okay, so this was just one-off thing, I guess. Only thing is, you start talking when I'm done speaking. Okay, not together. We should not be talking together at the same time. So when I've stopped, that's when you start talking. I'll give you enough opportunity to speak, so don't worry about it. All right, where were we in the last lecture?
Say in this classroom.
What?
He's
Dad
over
jokes.
smart.
Dad jokes.
Yeah, it's a PJ, poor joke. Listen, where did we stop in terms of second law of motion, if I remember correctly?
Inertia. No, inertia.
Acha, we are yet to start second law of motion?
Yes.
Okay. Sure. So have we done first law of motion?
Yes, I think. Yeah.
Okay. So in laws of, this is law of force and laws of motion.
We were discussing types of inertia.
Correct.
In this chapter in volume 2.
Yeah.
In this chapter what?
This chapter is in module.
Yes, it is. So you brought volume 1, I guess. It is in volume 2. Okay? So those who...
And you are supposed to bring volume 2, second volume 1 or
I
volume 2.
didn't get
I forgot to bring volume 2 also.
Ah, okay, next time, huh?
You can
Next time.
share it with Siddhi then.
Siddhi also
So it is second volume.
I didn't get
Okay, we have 2 volume 2. You can
So don't worry. You can so any okay, let's start from the start. Any doubt in balance and unbalanced forces? That is the first topic. Are you all clear with what is balanced force and what is unbalanced force? Is everybody clear? I'm talking to all of you. ठीक है. Second topic is, so okay, one question then. Balanced force. Let us say you have like a tug of war game. I told you, right? Let's say this is a rope and some marker is tied here, some handkerchief or something. People are pulling it in this direction. Let's call it F1, and also pulling in this direction, F2. When the forces are balanced.
When F1 is equal to
F2, right? So balance force means F1 is equal to F2, right? So when we say F1 is equal to F2, are they in the same direction? No. Then when the direction is not same, what do we say? F1 is in the negative direction of F2. That's what we say. What is the direction of F1? Negative. If it is left to right, right to left is F1 direction. Got it? Okay, so for direction, negative sign, right? So now then what does this mean? This means F1 plus, now this is minus F2.
Sir,
This is
why
equal
do
to
you
0.
minus again? Why do you minus?
Because F2 is same but not in the same direction, that's why. Not in the same direction as F1. So if I write F1 positive, then I have to write F2 negative. So what is the net force therefore?
So we can write any of the values as negative, right? And any of the values as positive.
No, one will be negative because both are of equal. Say for example, this is also
Yeah, that's
5
what I'm
Newton.
saying. F1 can be negative or F2 can be negative, right?
Yes,
And the other has to be
either, not
positive.
together, either. So that the sum total should be 0. Okay. So then we say that this is the net force F is equal to this. Net force. Now you got it. I think this was the question in the last time we got confused. Okay. So I write net force means total force. Either you write net force like this. F net is equal to sum of all the forces. F net is sum of all the forces, and that is 0. Now this can produce two things. When the net force acting on a body is 0, two things can happen. What are the two things? Either this thing will not move anyway. Okay, so two things may happen. Things possible when F net is equal to 0. So if I call this as, let's say it was some object, some body, and it was pulled from both the sides, right? No motion. Will motion take place if both the forces? No motion. That's one case, right? Second, uniform motion. So both are possible. No motion or uniform motion. What is uniform
How
motion?
is uniform motion?
Yes, we'll discuss that. What is uniform motion?
Object moving with same speed and
Yes.
same intervals of time.
Constant velocity. Same covers equal distance in equal interval of time. Okay. So what it means is its velocity is constant. That is v is equal to constant. So just store it in your head. Uniform motion means object is moving with constant velocity. Okay, that is what it means.
So what is the constant?
Yes. So it means acceleration is equal to 0. It's not accelerating. What is mean by constant velocity is what she just said. Equal distances covered in equal interval of time. Every 1 second the object is moving by 10 meters. So in 2 seconds 20, 3 seconds 30. Then the velocity is constant, right? When we say accelerated, first second 10 meter, next 15, next 20. Okay, so every second it is covering more and more distance. Then it is not traveling with same speed. Its rate of motion is changing. It is covering distance at a different rate now. Okay, so that is now then acceleration is then not 0. It is accelerating then.
Yes.
So if it is uniform motion, there is no acceleration. Okay, it means so many things. Velocity constant, no acceleration, all mean one and the same thing. No acceleration. Is this clear? Net force 0.
Acceleration is the change in velocity, right?
Yes, so it could be increase. Then we call acceleration. If the velocity decreases, we call retardation. Acceleration, negative acceleration is called retardation. See, if there is change in velocity, it could either increase with time or it can decrease with time, like
So can we turn
cycle.
off the fan and cold?
Both?
Yeah, both the fan.
Okay.
Thank you.
Okay. So everybody understood what is acceleration and what is retardation? Whether the body is accelerating or retarding, then it is not uniform motion. Got it? Acceleration or retardation, both are case of non-uniform motion. Is it clear? Yes or no? Now
Yes,
stop
sir.
speaking.
Yes,
You
sir.
say yes or no. Okay. So this is possible. So this is the second case. Example of this. I'll give you example of this. Now see. First example. Pull this book towards you. Is it moving? First example.
No,
You have to stand. Okay, you pull. Is it moving? First example. Now, moving with a constant rate. Sudden. So then it is acceleration. If it is moving at a constant rate, still net force is zero. Like here. See. Here I am applying some force. Okay? Is this book moving? How is it moving at a constant rate? Then also net force is zero. Why? Whatever force I am applying, the friction, there is a friction between the surface and the book. That is balancing it. Got it? When the body is
forces
in opposite direction. Yes, but there is no acceleration. Okay? Understood? So this is also net balance, net force zero. Because this is one force and the opposite direction force is friction. And when both the forces are equal, then it is moving with a constant
So
velocity.
balance force is supposed to happen when two forces
Are equal and opposite, yes.
Yeah.
And it can give you two results. Either the body is stationary or it will move with uniform velocity. Is that clear? Very good. So this is the external force. And if this is the surface on which the body is moving, then friction always acts opposite. Small force is friction. This is external applied force. Is that clear? Okay. So when applied force causes the body to move despite to move with constant velocity. Because I could have pushed it like this also. Then this is acceleration.
Yes.
Okay? Still there is friction force, but now it is accelerating.
Yes.
So that's not net force zero. Okay? So when applied force causes the body to move with uniform velocity, with uniform or with constant uniform. Despite the opposing frictional force. The net force is this zero in this case. Is it making sense to you all now?
I think you move your head a little bit. You just move entirely, I guess that would be more comfortable.
Why don't you change position on that desk?
It's very cool now.
Is it?
Yeah.
Okay. Okay. So I guess this settles the issue. Balanced and unbalanced force. Now, what is unbalanced? Obviously, in case of unbalanced force, the forces won't be equal. In case of so let's say In the same example, F1 is 5 Newton and F2 is minus 10 Newton. So these are unbalanced forces. It's obviously high in magnitude as well as in different directions. So now this is example of unbalanced force. Okay. So unbalanced force, what it will do?
It will push the object towards one side. The force which is greater.
It will produce accelerated motion in the direction of greater force, right? So it will produce accelerated motion in the direction of greater force. Okay? So this is your unbalanced force. Okay. So this is a bit of revision because I think this is where I think some of you got little overwhelmed. So I thought I'll do it again. Okay. After this, we did the concept of inertia. So this is point number 2. Point number 1 is, this is chapter number, what is this chapter?
Chapter 9.
This is chapter 9, but 8 in new book, right? I guess so. Anybody has new textbook? So 8 or 9, just check it.
8.
It's 8, right?
So which
8.
chapter got deleted?
The diversity of Bala. It's, I guess, bio chapter.
Just figure it out. I have a old book, so I won't be able to tell you. So, and today I have not brought it. Okay. Third topic was first law of motion. Okay. Then you have before second law of motion concept of momentum.
सर हमने माउंट अप नहीं किया.
क्या नहीं किया? हमने सेकंड लॉ भी कर लिया है ना, नहीं किया?
नहीं किया.
ओके, सेकंड लॉ ऑफ मोशन ये सब करेंगे.
माउंट अप करना
Still
है.
our first law and inertia.
We completed inertia. We
We
must
did
have
inertia.
inertia.
So inertia, let's rediscuss it. So everybody is clear on inertia?
Yes, sir.
So what is inertia? Anybody?
Body wants to stay.
सर
Wait, you both have answered so many. So I want to go with somebody. Okay, yeah.
The body wants to stay in the state of motion it's already in. It doesn't want to-
The last one.
Correct. And why it is so? That's the tendency of every body. है ना?
It's just
is a property.
Yeah, it is a property shown by every body to maintain its last state of motion. And this property is called inertia. Okay?
3 types.
So why it is? Question is, why is that property? It is due to
it's
mass. Wonderful. It's due to the mass of the body. Okay? So body with a higher mass will show higher opposition to the change of its last state of motion. Okay? So that's why if the body is lighter, it's easy for me to move it. But if the body is heavy, I have to apply greater effort. Why? Because its inertia is more. Okay? The opposition to motion in one word is called inertia. Okay? Opposition to motion, is that correct? Opposition to change of state of motion, that's correct. It's called inertia. Are we good till here?
Yes, sir.
Okay. So inertia is due to mass of the body. What is inertia? We have covered in the last lecture in detail. Now, what is first law of motion?
Sir, first law of motion states that the body will remain in a state of rest or in a state of motion unless there is any force that acting on it to change its state of motion.
Yes. So a body will continue to remain either in the state of rest or of uniform motion in straight line unless
Why not uniform, non-uniform motion? Can a
If the
not
motion
continue
is-
to be non-uniform?
In order to change
if it
the
is
uniform
not
motion,
in a
it
straight
gets
line,
forced.
then it is not uniform motion anymore.
Yeah, but
Because change of direction.
would the body not continue to stay in motion if it's not in uniform motion?
Non-uniform motion happens when there's a force which changes the uniform.
Then the force is acting.
Okay.
What's the condition? See, when the force is not acting, only in case of uniform motion or no motion. This is the thing.
Yeah, that I understood. I'm just
Friction is what
processing.
makes the body slow. And if
That's why physics is conceptual. It's not literature. So the sentences that we're speaking as a meaning, right? When I'm saying uniform motion, right? That means when the speed is constant, when the velocity is constant. Now velocity is a vector quantity.
Yes.
So when can velocity change? Either when its magnitude is changing or when its direction is changing. So if the motion is not in straight line, then the direction is changing. Then it has changing velocity. Then it is no more uniform motion.
Yes.
because the force is required to change its
Force is needed to change the
direction,
direction.
and that's not.
So every word has a meaning. That's why it is a law. So now read it. So every time you read it, you will understand it in a different way. So is it clear now? Is the first law clear?
Yes, sir.
Say that again. A body continues to
in a
be.
state of rest or in uniform motion in straight line until it
force.
experiences the external unbalanced force.
Yes. So if it experiences a force, then it is not uniform anymore. Okay? That's what it means. Is it clear now?
And so this is not supposed to happen only on a straight line. And I can't-
Only then the motion is uniform.
Sir, actually, it's the property still holds when it's when balance was absent. Right? It needs to be external unbalanced.
So there could be a balance force now when you are going straight, like in this case. I'm going straight. The applied force is balanced by the frictional force.
Yes, sir.
But
Sir,
it is still straight line motion. So net force is zero.
yes.
Everybody clear on the first law? Okay. So question is then why? Why a body continues to be in its last state of motion? Then the answer is due to inertia. Okay. So this inertia and first law of motion is same thing, right? That's why it is also termed as law of inertia. Okay. Then we learned about different types of inertia. So there are three types majorly:
Inertia of
rest.
Inertia of motion and
inertia of direction.
Right. Give me example of each one of them.
Sir, I'll say first.
I have no idea.
Sir,
Sir, inertia
sir,
of motion, inertia-
One second. You will raise your hand and I will choose. Inertia of rest, inertia of motion. I will give you an opportunity, don't worry. Inertia of direction.
So can I say for rest?
Okay, now the forum is open. First we go with inertia of rest. Who wants to answer? Okay, go ahead.
Sir, let's say I'll explain an example. So let's say you're on a bus which is currently at a state of rest. So you're also state of rest. When the bus accelerates suddenly,
Right.
you experience a sudden jerk backwards. This is because your body was previously in a state of rest. So while
Full body.
so when the bus starts moving suddenly, while your legs move with the bus, the rest of your body, because of inertia, tries to stay in its last state of motion, which was at rest. Which is why you experience the sudden jerk backwards.
Very good. So
This
only
type of inertia-
where is the jerk experience? In the upper
This
body.
type of inertia where your body tries to be in rest is called inertia of rest.
Correct. So where do you experience the inertia of rest? In the upper body. Because leg is already in the contact with floor. Leg tries to move with the floor. But the upper body just feels the jerk backward. Okay, that's inertia of rest.
Sir, I have another example of the AC.
Yes, sir. It's getting
Switch off the AC also. Somebody has a remote.
So shall I go ahead?
Go and get the remote.
Sir, if
First you check your.
No,
It's not there?
it doesn't keep it here anymore.
Okay, fine.
Inertia of rest, if we take a container and a square shaped cardboard and just place it above the container, means like cover the container with it when the container is open and keep a coin vertically above the container, and the moment when we means hit the cardboard straight means
That's the question she was asking. Okay. So this is a glass tumbler. You have a cardboard. Okay. So it is covering the tumbler like this. And on the cardboard you have kept a coin. Right? Now when you flick the cardboard, flick. Then what happens? The cardboard flies and the coin drops inside. Yes, this is what you were asking, right?
Yes.
You wanted to understand.
Sir, I understood.
Yeah.
I did that.
Right. So you did the experiment. Very good. So coin and cardboard, they are not glued together. Coin is freely resting on the cardboard. You just hit the cardboard like this. So cardboard flies and the coin tries to remain there. And therefore it falls in the glass. Tumbler, glass, container, whatever. Similarly, if you have a stack of coins kept on a carom board. Everybody knows carom board?
Yes.
So when the stack of coin is kept, right, and when the striker hits the bottommost coin, you must have seen just the bottom coin has come out and the stack remains as it is.
Yeah, that does happen sometimes.
That is inertia of rest of the coins.
If the striker is put too hard, only the bottom piece.
Only the bottom piece is removed. That is set into motion. Rest of the coins are at rest. They just land down. Okay? So that is due to inertia of rest. Inertia of motion.
Something is trying to move, it will try to continue.
Braking. Braking.
Sir, how braking? Explain.
We shall require an explanation to that.
Yeah,
Yes.
so you already have it in you, it's not just coming out. I'll help you.
We don't know.
Sir, if we apply brakes in some means immediately, then it happens that
It's
we come
slow.
forward
Yes.
and then come back.
No, you come forward. Come back to thigh, that's because of the muscles.
Yes.
But you come forward, right?
Yes.
Because the whole body was in motion. The floor comes to rest, the legs comes to rest, but the upper body tries to keep traveling. So that's inertia of motion. हाँ AC बंद कर दो बच्चों को ठंड लग रही है. Thank you. वो कहाँ चला गया?
Washroom चला गया होगा वहाँ से.
All right. So inertia of motion clear?
Sir, but how is braking inertia?
How will the speed suddenly go down? Due to braking, right?
Achha, that brakes. I thought this was.
They are not breaking an object.
Sir, can you explain again?
You're traveling in your car, okay? And the driver slams the brake. She's laughing at herself, huh?
Yes.
So that's fun, right? So it's not. So that's why I say English is very funny, right? It's not this braking. It's just braking, and both are braking.
Why do we read it the same? Why can't we read it bracking? I don't know. That's a possibility.
Okay? So
Bracking?
that's why French just hate English. You know that?
French is the language with the most amount of similar pronunciations.
Devanagari is the best. What you say is what you write. No confusion.
Yes, sir.
Like Sanskrit, yeah. That's why it is like most embraced language for computer programming.
English is based on French.
The grammar, no, English is some slang. God knows what it is. It's just accepted. It is just accepted.
It's a universal.
And grammar, anyway, it's a controversial area, but now I'm talking to you in English. Ironic. It's I don't know. Okay.
Inertia of direction.
Huh?
Inertia of
Inertia of direction?
Velocity or direction?
Inertia of direction.
When we are running,
When
when we go like this,
Inertia of direction means, so you try to maintain the last direction, right? So now see, if you tie a small pebble or a stone to a string and rotate it like this, okay? So rotate it. Let's say when it is in front of you, the string breaks. Where will it continue to circle?
no, it goes in
So everybody knows it, right? So what was its last direction when the string, when it was directly in front of you? Let's say somebody is rotating it, okay, and the stone was here. So where is the direction? What have I told you? It's always along the tangent. Have I told you this?
Yes.
Yes, sir.
I always seem to forget the word tangent.
Tangent. So in English, tangent has a different meaning.
Yeah.
Tangent. Some stray thoughts. Tangent. Mommy, Papa is saying something,
And you're thinking.
and you're thinking you're on your own trip.
Yes.
That's called tangent. In a direction, in your own direction, not in the direction you ought to be. Okay, so that's a tangent. And it is same in mathematics also. So every point has a different direction. That's why it is probably called tangent. Every point has a different direction. Tangent. Okay? Alright. So what it says is, since the last direction at this point was along tangent, so when the string breaks, now it is not circular, it just travels straight in the last direction. So that is inertia of direction. It is maintaining its last direction. Right? That's why when you ride a bicycle, everybody has ridden a bicycle. Okay. So when you go straight, it's easy. But when you take a turn, what happens?
Put in a little bit of.
If you take a turn straight, you'll fall.
Sir, we slow down the speed.
You slow down the speed, you bend your body also on one side.
Yeah.
Can you turn your cycle straight? You will fall on the other side. Where will you fall? In the last direction. Okay, so you balance it. So all those things are there. Okay, so that's inertia discussion. Now let's discuss momentum. What's the time now? 4:49. Wow. Okay. So everybody good till here?
Yes.
Momentum. So linear momentum, okay? Linear momentum. In physics, anything linear has got to do with straight line. Okay? Straight line. Momentum in a straight line. Now see what is 5 July. Okay. So what is momentum? It is product of mass of the body and its velocity. Okay. So what is the symbol for momentum? P. Small p, and it is equal to m into v.
Mass into velocity.
Yes. That is how linear momentum is defined. Okay. So if you have a body whose mass is 10 kg and it is moving with v is equal to
5 kilometers per hour.
60 meter. Okay, chalo, 5 kilometers per hour.
Yeah, then we'll have to.
Why not meter per second? Okay, keep the unit same. Kilometer per hour, then you'll have to convert. So, what is the momentum? Then its P will be
600.
10 into 60, which is
600.
600 what? Kg meter per second. So, this is a derived unit. Okay? Because momentum has mass and velocity. Mass unit is kg, velocity unit is meter per second. So momentum unit is kg meter per second. Clear? Okay. So now let's do two things. Let us say now this was its initial speed, initial velocity, and then its final velocity is, let's say it accelerated and it went up to 100 meter per second. Okay, so this is V now. So both. So what is its initial momentum? P initial is mu. Okay, u is initial velocity and P final is mv. Is it clear? Product of mass and velocity. So this is initial velocity, this is final velocity. So we have both initial and final momentum. What is initial momentum? 600 kg meter per second. What is final momentum? 60 into 100. Sorry. 10 into 100. So this is 1000 kg meter per second. So is the difference clear? What is initial momentum? What is final momentum? Is it clear?
In initial and final momentum, I didn't understood.
The same body started at a lower speed, 60 meter per second. But then it accelerated with time and it reached a speed of 100 meter per second. Possible?
Yes.
Yeah? So then what is its final momentum? Initial momentum was less, 10 into 60. Final momentum is 10 into 100. Body is same, no? Mass remains constant. Mass of the body is constant. What is changing? Only its velocity. So its initial momentum, I means initial. Let me write initial momentum. Why initial momentum? Because u, initial speed was symbol. Everybody remembers what is u? Initial speed. V is final speed. So therefore momentum will change if the speed changes. Right? Because mass cannot change. So change of momentum has to be due to the change of speed of the object. Correct? So that's what it is. This is final momentum. Yes.
No,
Nothing?
sir.
Yes.
Can you explain momentum?
Momentum is product of mass of the object with its velocity. And it is important in defining force. That's why we are learning momentum. Okay?
I don't know, momentum just doesn't make sense to me.
Yeah, it will make soon. So your mother calls you 3 times. You don't respond. What happens next?
I am homeless on the street.
Beating.
Beating. Not homeless yet.
Never get yet.
First you will be disciplined. Come on. So when you come in one call, pat.
That's
Same
why
slap.
I don't get beat at home.
Okay? The mass of mother's palm is same. You respond in 10 calls and she is furious.
I
This
do not
time,
have a home.
this time, momentum too high. Okay? So momentum causes impact. Any object traveling with higher momentum will cause a bigger impact.
Sir, can you define momentum?
Without using.
Sir, I did not understand the definition.
It is the product of mass
So
of
what
the
does
object.
it do?
That's what I'm telling you. So impact. It causes impact. See, it's like this.
What?
Let's say I throw it towards you. Are you good at catching?
Yeah,
Let me
I
try
am.
with it.
No, sir.
Sir, I play hockey. I'm
Play
good
hockey?
at call catching.
But I need cricket ball. See, he threw towards me gently. Now if I throw it so fast, and if you miss it, first case nothing happens to you. Okay? Throw it back gently, huh?
It was very gentle.
Okay. Now little up. It's coming fast, huh?
That was too fast.
That was too fast. What if it had hit you? the impact will be much more.
Yeah.
Where is it?
So you make physics.
Get up and get it.
Sir, you make physics fun.
I know. That's why I was surprised to get all zero. Huh?
Ooh, what's that?
Okay. So a gentle throw, same object. Is it mass changing?
No.
No. A gentle throw doesn't cause. It's stuffy now, right? Can I?
Yes, sir.
Won't turn on the fan over here.
Same. Which fan is this? Is this the one? Yeah. So the same object causes different impact with the change of velocity. I have to land this on everybody's head. First slowly, then little fast. She's not. Who asked me momentum question? Huh? Do your hand like this. नहीं hand ऐसे करो यार.
अरे वो डर गई है.
लगा? हंसोगे तो फील नहीं होगा. लगा?
हंसोगे तो मोमेंटम नहीं फील होगा. हंसो मत. Inertia में रहो.
The new physics concept.
Second case momentum was
momentum.
no.
I have developed the sixth law of motion.
Okay.
Physics में नया concept मिला है.
एक मिनट. Okay. ये देखो. ठीक है? Little impact. Is it changing?
No.
Now just imagine your finger is here.
No.
Huh? What will happen?
Impact.
Bigger impact. टूट नहीं जाएगी. Understood? So this is momentum. It has got to do something with force.
Okay.
Clear?
Yes.
So what is the definition?
Sir, it is the product of
Mass with velocity. Now tell me, this duster momentum. This duster momentum. First case, let us say it is 10. Let's say this is 10. Okay? What is this?
100.
100.
Sir,
3 times maybe.
So
Right?
basically momentum is mass times velocity, right?
So what else am I saying, my dear?
Anurag, you just say the things every teacher says back to them. And
Which is good.
No, he acts like it's his own definition.
So when the realization happens, right? So this is after realization, and then it was before pre-realization, after realization. Anything changes word-wise? No. But the meaning is got it. Okay? So momentum, right now you understand momentum has got something to do with force. Okay? Now see, I am going like this. Okay? And I try to walk out of the door. What happens? What happens? Since I was walking slowly, I am still in one piece. Right? Now let's say I run and bang into it. What happens?
So
A
depends
few
on the
broken bones and broken pieces.
Do we need some demo?
Anurag, go. Show us.
No.
See? So you understand what momentum can do to you? Now when you feel the force, okay, let's come to the point. When do you feel high impact? Right? When the momentum changes suddenly. Listen, I had some x momentum. What is my momentum now? 0. From some finite momentum, it suddenly becomes 0. So is it becoming 0 suddenly when I'm walking slowly? No, it becomes 0 with some fraction of second. What if it becomes 0 suddenly? Boom. It's destruction. Accidents. What happens in accidents? 2 vehicles moving suddenly come to rest. Large impact. They will both be history. Imagine 2 friends meeting after a long time, running slowly. Okay, they met.
Collision.
They met and they survived. Then they run and they ram into each other. What will happen?
It's just one excited or things.
Huge impact, and then people
Some
will
friends
only
no more.
read about them, right? Gone. So when momentum changes suddenly, it causes great impact. Okay. So next is rate of change of momentum. What next? Rate of change of momentum.
Sir, when the rate of change of momentum
Wait, rate of change of momentum. What is it?
Sir,
It is equal to final momentum minus initial momentum upon the time. Okay? So this is change in momentum. So first let's say what is change in momentum. We have already done, right? So rate of change in momentum is change of momentum upon time. It is called rate of change of momentum. Everybody understood?
Yes, sir.
How the momentum changes? I showed you when the time is less and when the time is more. When the time is more, the rate of change of momentum will be less. If denominator is more, what will be the result? Less. What is big? 10 by 10 is big or 10 by 100? What is greater?
10 would be greater.
Right? This is 0.1. Isn't it? So when the denominator increases, the overall answer reduces. So when the time is more, that time rate of change of momentum will be less. Okay? The rate of change of momentum itself is called force. Understood? What is rate of change of momentum? Force. So the force will be more when time is, the change of momentum time is small. Understood? What is rate of change of momentum? The impact will be more if the momentum changes in a very short duration. Short means big. Short in the denominator, small in the denominator. Okay? So you've been learning mathematics, all these fractions, but you have never not been realizing it. You were like reading it just to solve numericals. But you have to understand, it has impact in life. Okay? So that's why.
It is made to fall on a cushion or something like
Ah, so if this falls on a floor, right? But if it falls on a cushion, when it dips,
decrease the rate of change of momentum.
is there an impact? Let's say instead of falling on bench, okay? Now, same height. Is there impact?
Yes, sir.
Is there impact? So she is brilliant. Okay? Is there impact? Same height, more height also, no impact. Why? Because if you see in the slow motion, it is touching it, pressing it down, and then coming to rest. So there is time.
Coming to rest slowly instead of suddenly.
Yes, the momentum is changing slowly, not suddenly. Whenever there is a sudden change of momentum, impact is no. How will you feel the impact? Okay.
Sir, by increasing the time.
So momentum is just impact.
Yes, by increasing the time, you are reducing the impact. Okay, so unless you involve time, so rate means time. How the momentum is changing with respect to time, that decides impact. Okay,
So if there's a decrease in time, then less impact, right?
more impact, decrease in time. Decrease in time is
Less
momentum
time,
changing suddenly.
more impact.
Yes.
And
More time,
less
impact. Yes, because it is inverse relation, not direct relation. Some of you are still giving me a puzzled look.
No, I'm kind of.
Are you understanding? Okay, so when the momentum changes suddenly, more impact. So that change is called technically rate of change of momentum. Okay. This putting in a statement is second law.
Sir,
The same thing put in a statement is called second law. So what does second law?
is it like something like if a force is
Now listen. So what is second law of motion? Force acting on a body is directly proportional to its rate of change of momentum. This is second law. Today all my ratings are going to get changed into excellent. I'm dead sure about it.
I don't even know how.
Force acting on a body is directly proportional to its rate of change of momentum. So, where is the force acting when I am hitting this door? On me. So, when my momentum changes suddenly from so much momentum, let's say 1000 kg meter per second, now suddenly 0. So, what's the change in momentum? What's my final momentum? 0. What was initial momentum? 1000. So, minus 1000. Minus means the force is on me. Okay? Is it understood? And in how much time? Let's say 0.1 second. 1/10 of a second. Because when I'm colliding, 0.1 second, right? So then it will be like 10,000. It will be 10,000 kg meter per second square. That it will be. What is force? Kg meter. So what is this unit? Okay, we'll define it here. So this is the second law of motion. Force acting on a body is directly proportional to its rate of change of momentum, and it acts. What acts? The force in the direction of change of momentum. It acts in the change of momentum. Or change of okay. So any confusion till here?
Sir, can you explain how force acting on body is directly proportional to its change of momentum?
I just kept banging on the door to explain you just this.
Both man has not said too much.
What was I doing then so far? The same thing, I have written it in the form of statement, and we call that second law of motion. Okay, I demonstrated this and then I put it in words.
The rate of change of momentum is
Force. And the last part is in what direction the force acts. So when my momentum was initially like this, now change of momentum is negative.
Okay.
So force is acting on me.
Yes. Okay.
Sorry, sir.
No, it's okay, it's okay. It's all right. Can I erase the left side?
Yes.
Okay. It's all entering in the head because we did a lot of hard work in the last class.
Yes.
I'm sure definitely did a lot of hard work last class.
Okay, so now let's derive the equation or the mathematical form of second law of motion. So by this law, therefore, F is directly proportional to change of momentum, rate of change of momentum, right? Change of momentum upon time, right? That's rate of change of momentum as per this. So therefore, F is equal to, whenever we replace the proportionality, we replace it with constant. So this is equal to change of momentum. What is change of momentum? P final minus P initial on time. Isn't it? Rate of change of momentum.
What is K?
K is the constant, where K is constant of proportionality. Okay, K is the, so whenever you remove proportionality, you substitute it with some constant. Okay, that's the rule in mathematics. Ratio and proportions, have you studied?
I have studied this in RMO.
Yeah, so wherever you have studied, what you need to learn is whenever you remove proportionality with,
We need to
replace
put
it
in
with
constant.
equal, you have to also put a constant. Okay, because this is not equal without the constant, right? For example, 2 is proportional to 4. Is 2 equal to 4? When is 2 equal to 4? When you put a constant. Okay, then it is equal to 4. It is proportional but not equal. Equal hoga when you multiply it with a constant. That's the rule. Okay. So now, so F is equal to K. What is TF?
P final.
MV minus MU. We did all this, right? P is final momentum, I is initial momentum. Therefore, K M V minus U by T. And what is V minus U by T? Change in velocity upon time. Acceleration is improved greatly. This is called acceleration. So all these things have to start registering you now. There's nothing we are doing new. Everything is coming from previous discussion. We're just formalizing it mathematically. So this is the mathematical form of second law of motion, right? So now we have to choose the unit of force in such a way such that value of K becomes 1. Choosing F is equal to 1 unit when M is equal to 1 unit and A equal to 1 unit gives K is equal to 1. Okay, so that is 1 unit of force is equal to K times 1 kg and 1 meter per second square. If you substitute value of M, A, everything 1, 1, 1, then what do you get? K is equal to, so K will be 1. Okay? So you use the unit of force in such a way.
That K will be equal to.
So this, therefore, now I am removing all this. Therefore, F is equal to MA. Right? This is the formula for force. So how much force is acting on a body? It is just equal to product of its mass with its acceleration. शर्मा मारेगी माँ इसलिए फोर्स लगेगा माँ मारेगी ओके ठीक है so this is the mathematical form of Newton's second law of motion, right? So what is 1 Newton? Unit of force is 1 Newton. Is how much? 1 kg into 1 meter per second square. So this is 1 Newton. 1 kg meter per second square. This is the relation between Newton and kg meter per second. So which force we call 1 Newton? A force which produces acceleration of 1 meter per second square in a body of 1 kg. That force we call 1 Newton. So if this is 1 kg, Okay, if I apply a force such that it produces 1 meter per second square in this, then the force I applied is 1 Newton. Clear? So we'll stop here today. You took the attendance with him? Okay. Okay, I'll see you in the next lecture.
Thank you, sir.
Thank you.
Yeah. बस मेरा नाम
गाइस जब तुम लोग नहीं हो तो मैं अदिति पे लेट
लेटी थी मेरे ऊपर अरे मैंने
मैंने स्टोरी पे डाला
उसने उसका डॉग भी मर्डर कर दिया
क्या
स्टोरी पढ़ रहे ऐसे
या आई नो
उसने उसका डॉग मर्डर करे एनपीडब्ल्यू से बचाओ कंट्रोल करने आया था
हाउ क्रेजी इज दैट आई थॉट यू सॉ इट कमिंग मैं उसने जैसे ही डॉग मेंशन किया ना
अरे मेरे को लगा वो वापस कर दिया
आई वाज लाइक